Welcome to Concentration Units 1, Molarity Review Part 2. In this video, we're going to look at two more problems involving molarity to review before we work towards looking at some new kinds of units for concentration in the next videos. Okay, question number 1. How many moles of chloride are in 4.5 liters of 0.155 molar iron 3 chloride? As always, make sure you pause the video and try to work out the problem on your own before viewing the answers. So again, because we're dealing with molarity, we might need to know moles of things, formulas of things. So we have translated our words of iron 3 chloride into the formula. So iron 3 means it's iron with a +3 charge. Chloride is the anion for the chlorine, which likes to have a -1 charge. So we'll need 3 of those chloride ions for every 1 of our iron. Okay, and I will go ahead and rewrite again our molarity as a conversion factor. So I'm not tempted to use it as my starting point in my conversion. I'm reminding myself that molarity is a conversion factor, like all concentration units. So 0.155 moles of iron chloride for every 1 liter of solution. I'm also going to be very careful to keep track of both the unit and the material. Remember, with concentration units, it refers to 2 different materials in the numerator and the denominator of that unit. So for molarity, the top unit is moles of the solute, moles of our iron 3 chloride, and the bottom unit is volume, liters of our solution, the mixture of both the solvent, which is water in this case, and the solute, our iron 3 chloride. All right, so I'm going to start with what I am then given, which is the volume. We have a container, a bucket, if you will, that contains some amount of that solution, so many liters of our iron 3 chloride solution. And we are looking for moles of just the chloride, okay? Not actually even the moles of the whole solute, but moles of one part of the solute. So we'll have to account for that when we make our plan. So I can get, again, from liters of my solution to moles of my solute, which is the whole compound iron 3 chloride, using my molarity. So that's the red arrow conversion to match the information in the red box there for molarity. And then I need to convert from moles of my solute, the iron 3 chloride, to moles of just one component, one part of that compound, to moles of just the chloride ion. All right, so here are the conversions. So the relationships we'll need to use the molarity as a conversion, as we've mentioned, for that first red arrow. And then the second conversion is a mole ratio. Did you remember how to find mole ratios from chemical formulas? Right, those subscripts tell us the number of moles of individual, in this case, ions, relative to 1 mole of the whole compound. So we can use that chemical formula that we got from the name in order to find our mole ratio. So there's 1 mole of iron 3 chloride for every 3 moles of chloride ion. That's what that little 3 subscript after the chlorine in the formula tells us. All right, so we can again use dimensional analysis to help us get those units in the right place. And then we can pick up our calculators and again, still be mindful of significant figures. And we end up with 2.1 moles of chloride ion. All right, our last question for this video. You have 25.0 milliliters of 0.155 molar barium chloride. To what volume should you dilute this solution in order to have a 2.5 times 10 to the -3 molar solution of barium chloride? Please pause the video and try and work out the solution on your own first. All right, well, I hope that you were able to deduce that this is a dilution problem. So we can use M1V1 equals M2V2. So our initial, if you will, molarity and volume, what is our starting condition and what is our final condition? What are we trying to end up as? We need to identify all of that information. So what we start with is 25.0 milliliters of a 0.155 molar solution. So that remember that word of connects that volume, 25.0 milliliters, to the concentration, 0.115 molarity. Those two are for the same solution. So that in this case is going to be our initial or our starting, our more concentrated solution. We'll call that situation 1, so M1 and V1. And M2 then is what we're trying to find, what we're trying to create, I should say. 2.5 times 10 to the minus 3 molar solution. So note that it is more dilute, less concentrated, which makes sense since we're going to be diluting it by increasing its volume. And that's what we're going to find out. What is that final volume that we need to change our solution's volume to? We'll do that by adding our solvent. Okay, now I can leave my volume in any unit I'd like. Just realize that when I do my calculations, the volume that I will calculate, volume 2, will also then be in milliliters. So I do not have to change it to liters. You can if you'd like to, but it is not necessary. All right, now I need to do some algebra. And again, keep track of significant figures. I'm limited to 2 significant figures by the 2.5 times 10 to the minus 3 molar value for our final concentration. So our volume 2 is 1200 milliliters. So in order to create the solution with the desired concentration that's much less than it was initially, I would need to take my 25.0 milliliters of that 0.115 moles per liter solution and add enough solvent until the total volume was 1200 milliliters. Thank you for joining me for Concentration Units 1, Molarity Review, Part 2. So this concludes the Molarity Review section of this series of videos. So I hope to see you in our next video where we will look at some new units for concentration. See you soon.